or infection. Well, let's talk about hemoglobin for just a moment. This is a visit back to Chapter 17. You might recall from Chapter 17 that parts of hemoglobin are broken down and recycled. We actually take some of the pigments from hemoglobin and send them to what other organ? Liver, good. What do those pigments make in the liver? Bilirubin, good, which is part of bile. And so that greenish yellow color that comes from bilirubin and bile can leave your body by way of your feces and stool. That's what turns your feces a brown color. And some of that bilirubin is broken down into another component, another type of pigment that's actually exuded in your urine. It's in your bloodstream. Your kidneys filter it and get rid of it. And this breakdown product of hemoglobin is removed in your urine. So the yellowish color of urine is also coming from hemoglobin breakdown, but it's not hemoglobin in the whole form. It's hemoglobin that's already been catabolized and broken down. So interesting how hemoglobin colors both our stool and our urine. Different colors, obviously, but the ultimate color guide here comes from the hemoglobin process. Hemoglobin, though, here on your worksheet, we're talking about hemoglobin in the whole form, not broken down hemoglobin. So this could indicate hemolytic anemia, transfusion reactions, burns, severe burns here, renal diseases. Those types of issues can place hemoglobin in its whole form in the urine. Hemoglobin in its whole form is usually attached to what?
Red blood cells.
There you go, red blood cells. So if you're losing red blood cells in their whole form, then the hemoglobin comes along too. White blood cells, as you might expect, would only travel through the wall of those glomeruli if you have an infection. We call this condition pyuria, meaning that we have pus in the urine. Bile also should not be in its whole form in the urine. It should be broken down into its components. So bile in the whole form can also turn the urine a different color than the light or dark yellow that we're used to seeing. So bile in the urine could also indicate a liver disorder. Notice the range there for pH values is really wide open. pH of urine could be anywhere from, say, 4.5, which is a mid-range acid, all the way up to about 8.0. So what dictates the pH of our urine?
The diet.
Yeah, our diet, exactly. So what you're currently eating will influence the urine that you put out in the next few hours. So if you're a meat eater, or if you're a vegetarian and you prefer to eat, beans or protein-rich vegetables, any kind of protein breakdown is going to produce an acidic urine. If, however, you eat a meal, say nothing but salad, I'm talking lettuce, tomatoes, maybe some onions, not protein-rich cheeses or anything else that might have protein in it, but strictly an alkaline ash diet will produce a more alkaline pH in your urine. So actually what you eat can influence your urine pH, and urine pH doesn't necessarily indicate whether you're sick or healthy, it just simply indicates what you've been eating most recently. Urine pH can also depend on what your blood pH is doing because, heck, if you're in acidosis, we can get rid of more acid-containing ions, or if you're in alkalosis, we can let more of those bicarbonate ions leave our body. So blood pH is also going to help, influence that urine pH as well. In a 24-hour period of time, how much urine does a typical person urinate?
1.5.
Yeah, about 1.5 liters. So on average, during a 24-hour period, about 1.5 liters of urine is produced. Notice all the different things that can affect urination, everything from temperature to mental condition, how emotional you are or upset you may be, even diuretics, blood composition, if you've had a caffeinated drink or alcohol. All these things can influence how much urine we put out. Number 5, we talk here again about hemoglobin, and there's that color of yellow. You'll notice in italics on the second line, urochrome is the color of our urine. That's that yellowish color. If you have rather concentrated urine, dark yellow urine, you have more urochrome per the volume of fluid that you're putting out. That dark yellow urine makes us think we're currently what? Dehydrated, yeah. And the lighter, more dilute colored urine makes us realize that we've probably been drinking enough to flush out extra fluids. So that color, that urochrome pigmentation, actually can be, a light yellow depending on how much fluid you have to dilute it, or dark yellow depending on how few fluids you have in your urine. So what's the deal with specific gravity? What's a good number for specific gravity? 1, closer to 1.001. Pure distilled water with no solutes is 1.000. If you have extremely dilute urine, meaning you've been drinking a lot of fluids, then your urine will be very close to 1.001. Not 000, because that's just pure distilled tap water with absolutely no solutes. But we're going to be very close to that if you've had an extreme amount of fluids to flush out your system. The high value for specific gravity is 1.035, and that means you've got very concentrated urine, lots of solutes, and it's much more concentrated than something like dilute urine. So what's the problem with having consistently concentrated urine close to 1.035?
You need to drink water.
You need to drink water, because what can all those solutes do in your kidneys?
Cause kidney stones.
Cause kidney stones, exactly. So consistently having a high specific gravity definitely indicates you need to drink some more water. But the real issue here is those solutes gain together in your kidneys and hang out and have a party. The party becomes renal calculi, fancy language for kidney stones. So that's why, flushing with enough fluids does help to prevent having those solutes gain together. The odor there, the last thing, is, of course, something we're all probably aware of. The slightly aromatic odor of urine is first 24 hours after the urine has been deposited outside of your body. After that period of time, it really develops a more strong ammonia smell. So, of course, that ammonia odor comes from the breakdown of proteins. Ammonia contains nitrogen, proteins contain nitrogen, so that's where we get that odor from after a long time. This is gross. Back about 2,000 years ago, Greeks actually tasted the urine. Yuck. Who would do this for a taste test, right? What are they testing for? Sugar, yeah. People who are diabetics excrete sugar in their urine, and I guess that's how they confirmed that there was sugar there, by tasting it. Not going to be my job, right? So, of course, diabetics have a fruity smelling urine coming from the glucose that's being secreted there. Hey, in addition to fruity urine, they also have a fruity breath smell as well, because that indicates they're probably in what?
Ketoacidosis.
Ketoacidosis, yeah. Breaking down on those fats to make sugars for their body.
Before you get kidney stones, would you have an acidic urine and it be concentrated?
I'm not sure if
it
it may be acidic. It may also depend on what type you have. If you have like the citric acid type kidney stones, it may depend which form you've got, yeah. But I think probably one of the biggest indicators is that specific gravity being consistently high. So just a little history there on some urine information for you. And the last page here, 121 and 122, just talks about the pathway of urine out of the body. How about questions so far? All right, well, when urine drips from the renal pelvis of the kidney and travels down these ureters are tubes that operate by peristalsis, just like the tubing of our digestive system. So since peristalsis occurs in these ureter tubes, what kind of muscle is found in the wall? Smooth muscle, good. You'll notice that here we have 3 tissue layers in the ureters, and also in the, it says in your worksheet 3 tissue layers of the urethra. That should say of the ureters. You'll want to make that change on the top of 121. 3 tissue layers of the ureters. How many tissue layers did we have in the digestive system?
3.
GI tract was 4.
4. Good. We had mucosa.
muscular.
2 muscularis externa.
Good. So we had a
submucosa.
Good. Well, starting from the inside, mucosa, submucosa, 2 layers of muscularis externa, and then an outermost serosa. So here you'll notice that we only have mucosa, muscularis, and adventitia. What are we missing? Submucosa. Yeah, so we don't have a submucosa here. Back in the digestive system, that submucosa was home to blood vessels and nerves. We don't really need that setup here with the ureters. We mainly need those muscles to help milk along the urine down to the bladder. All right, so in this case here, we call the outermost layer the adventitious layer rather than the serosa layer. So notice there's a slight name change here. The only job of the ureters is to